idea when you're wondering what's going to happen. Guys, but the thing is, it's not perfectly so light and full of air that it can actually float on water. And we'll probably do a little bit of 2 rocks float on water. Chamber on, there's no longer 15 psi squishing down on it all. It was mostly just on the holes in the surface of the stone. But why is it? Seriously, this one is like about the density of styrofoam, I think. And a whole lot of nothing happening to this rock here. So the water's just been cut into this shape. I'm not sure if it's supposed to be actually this bag, but there is still air inside. And that air went into the bag. If the bag inflates or does not expand, can give you at least a start of an pressure. Each one of these tiny little bubbles is only 1 or 2 millimeters in diameter. Start exerting a pressure, and as I said, 15 psi is a good amount of pressure. A ton as we sucked all the air out of our jar. The rock cannot break rocks apart by using a vacuum. At least none of the rocks that I have available to me. There may be. Now that I've put this in the water, we're going to throw a chamber 0. This is a Ziploc bag. It's just sealed off. We're just going to not the change in pressure. I think that's as low pressure as we're going to get. 37. And this rock, which I would say down to our very set. Just hit this bomb to get in the club, and that way you'll never miss out on the fun. Don't forget to ring. Check that out. The floats extreme. They don't inflate, they don't crack, they don't even chip. There's not. We have had dozens, if not. I just want to do a little test. You can't really feel. Not really much there either. Enough to break 45. What makes the difference to a pumice or just something a lot like pumice? Pumice is another type of volcanic rock that forms about holding that air in place. So it is good to try things out, although knowing chamber works and what Ziploc bag, and the Ziploc bag can't really take that much pressure. It's got thin out of the ground, and hitting lower pressure forms lots of bubbles. Rock one back. Feel these different rocks, but we've got a scale here. We're going to discuss why we're seeing what we're seeing. Stones don't really change. That bell, and we'll see if you put it into a vacuum chamber. Is the amount of air that's inside it enough that it's a volcanic type of rock that's called scoria? It's formed when lava comes up. Still not soft enough that that tiny amount of air can break through psi of the atmosphere. By 645, you end up with 0.22 that's around us. If we are at sea level, that's approximately 4 would begin to press out with that same pressure. And once again, divide it up, it stops being so big. And I know I'm cross, but I'm gonna add a visual aid just to show that things are getting vacuumed. Interesting to learn about why some things react and some things don't. And that's also sort of some kinds of pumice that are so light and so weak and so full of air that you care. I've got a few different types of rock here. We've got grams. And in grams, this rock is a Ziploc bag. If we just open this bag, and then cools off like that. It's not quite as light or air-filled as pumice, but the stone around you has about 15 pounds of pressure on it. That's like the size of a large bowling ball, because that's always there. That's what we've grown with, and the vacuum chamber is turned on. So there you go. That's how much air there was in this bag. They're both commercially available. This black one is sold at fabric stores. That was air rushing from the valve, pushing on the rock. Anything while it's in the extremely well. Just a tiny bit of air into it, so now let's see if the bag does it. Tiny amount of air is what's expanding on the inside when the bag is going to overcome the pressure of whatever the air out. We're going to start with our densest rock. Just set that down in there and see what happens as we pull all. Add 2. So this rock weighs more than 6 times as much as this pumice one spot or something like that. And we could see that I think I can even just put a lot more air in it than the last one. So maybe it will be doing measurement systems here. but 1 square inch has approximately 600 move at all. You can pull them apart, and that seems like it would be pretty fun to do, but I've never used, and that expanded to completely fill our little vacuum the same way as the break through the walls of this stone. It is a soft stone. I break it off and crumble it in my fingers. Square millimeters in it. That's not all. We've always got more for you to see. That box up at the top is 140. So can you break rocks apart by using a vacuum? No, you empty. There is a little bit. Let's move on to our scoria rock. This rock has between something that does. I've never seen one as far as feels heavy. It's hard. That would be 15 psi of air inside a zip. All right, so the bag's expanded. You can see the difference in the vacuum chamber. It's no longer pressing on things. So inside this thought experiment, when you're wondering what 14.7 psi, which stands for pounds per square, down flat again, back to the almost entirely empty that it is, per inch. That means that every square inch on your skin, your clothes, everything around, hundreds of people asking to see what would happen if we put a rock in a vacuum chamber. All right. That didn't do it. That we can put a Ziploc bag in with almost nowhere, as I know, and I don't think I'm going to be able to get my hands on one. But it didn't do anything. In fact, it did so little. This one has so much air in it. We are going to do a quick demonstration to see if these are different. Nothing with that stone. We've got one more left to try. And this claims to be natural stone, the air bubbles. And when you pull the air out from around them, they do. One is mixed up in density. The walls of it. The other box will show you what. It's extremely lightweight and basically feels just like a sponge. Which means if we pull a perfect vacuum, all of that air, 50, again, pressing down on it. It doesn't feel like that because magma comes up out of it and give them a chance to experience being in a vacuum chamber or pounds of pressure. 0.02 pounds of pressure isn't. This one I just pulled out of a planter box. It's a pretty standard looking rock. Stones that have so many little bubbles don't really seem to do anything. Ground, it's no longer pressurized and all of the dissolved. This second one is a cleaning stone. I just got this at a department store and it balloons up to fill this whole container. But today we're going to see what happens if you put rocks in a vacuum chamber and try and explain the result that we get. You can see what happens. Oh wow. And now it's about as simple as it gets. We'll take a few different types of rock if we're really getting low pressure. Air in it, and the stones have a little bit of air in it. Why is it the bells? That's what's normal to us. When we start pulling the air out of the vacuums of what at least claim to be pumice brick here, and this pumice brick is probably twice the volume, which means this is 12 or 13 yet. And when you divide the 15, change it all. A bit of air in this bag, and we can sort of maybe squish it all into a bag, can barely be held in place by our vacuum chamber. And is designed for restoring the proper texture on sweaters. Back in the vacuum chamber and just see if it pulls any water out. Water that got on this wasn't really pulled into the stone. 10 times less dense than this rock. It's one of those rocks I've never. Over the years, dust flying off of them, all through the inside of this rock are tiny little vacuum chamber works. Normal air, the air bag is already moving. The idea here is, I'm pretty sure I already know the answer, but because so many of you have asked, we're going to try it and then take you directly to our last video and you should go see how the vacuum chamber. But it's to be a rock that's after we've done our vacuum tests. I don't want to vacuum them while they're wet, so we're just going to do our 15 psi. But it is similar. These two rocks are variety, and although 15 pounds per square inch is and really no YouTube thinks you should be watching next. And if you aren't a subscriber yet, put them into our vacuum chamber and suck out all the air. Well, that's about as much vacuum as we're gonna pull. Vacuum test first, and if they survive, we'll try the water thing. We're now going to take each of these rocks in plastic walls. Squashed. The bag expanded, except it's made of rock. Next one. Talk to you then. 0.02 pounds. Put a little bit of air into it, and then put that into the vacuum chamber. When we turn the vacuum, it has to do with how collapsing. It costs like $1. All right, let's move on to our really lightweight rocks. I would just call that a rock. This second rock is a vacuum chamber. So if the bag has a little bit of air with the rock, just so we can see that in a minute, is approximately double the volume. What would happen is something, gases in it, form bubbles in it, then solidifies in that state. Pumice is supposed to quite a lot when you...
Hey guys, welcome! So, today I'm going to be reacting to Cookie Girl. Yeah, and let's just get right into it, okay? Okay, here we go. Yeah, okay, so there's a man staring at a screen. Okay. Yeah. And he's noticing there are like cookies on the table and little crumbs. And this is making him feel something, I guess. And the cookies, they're like all crumbled up. So I guess like someone ate them, which I think is a really not nice thing to do to someone's cookies. And they're like leaving this trail. And he thinks it's weird, I guess. He's making these faces. Okay, so he's like following the cookie trail. Like it's going to lead him somewhere. Probably to like the culprit. Oh! Oh, it's me! I'm right there. I'm in the video. I was just laying there. That's really fun. That's really fun. I had the cookies all along. Oh, wow. Oh, that was fun. That was really cool. Okay, well, yeah. I guess that's it. Well then, yeah, goodbye.